Lesson 1d-Water. Last day we talked about water and how it was polar. The fact that oxygen, in the middle, has two non-binding electrons around it gives it a negatively charged region and a positively charged region, since the entire molecule is neutral. Water, in fact, is highly polar. That means that it attracts, among other things, other water molecules. When like material is attracted to one another, it's called cohesion. This water cohesion is created from the positive polar end of water molecules sticking to the negative polar ends of another water molecule. This repeats and creates a network of water molecules. This polar nature of water will even allow it to be attracted to other polar molecules, like glass. This is why we see the meniscus. The water is attracted up the glass side before the water's own weight keeps it from going any higher. This attraction between the two unlike substances is called adhesion. On a wax car, the water molecules cohere to one another, but because the wax is nonpolar, the water pills up trying to minimize the contact with the wax. Water also has something called high specific heat capacity. Heat capacity is the water's heat holding limit. In this video clip, water heats up slower than the sample of soil with the same source of light shining on it. It can absorb more heat and energy without great temperature change. This gives it a high specific heat capacity compared to things like soil. Because of the many hydrogen bonds holding water together, it takes a lot of energy to have the individual water molecules break free as vapor and to evaporate. This means that water also has a high heat of vaporization. The temperature for water to boil because of these hydrogen bonds is 100 degrees Celsius. The numerous hydrogen bonds holding water molecules together to form water also gives it a trampoline effect on its surface, which we call surface tension. Surface tension is what allows for things like water striders and paper clips to float on the surface of the water. Water also has a strange phenomenon of being less dense as a solid than when it's a liquid. This is due to the fact that when it forms ice, the individual water molecules become more rigid, and more space is needed, making it less dense. The fact that water is polar means that it's a terrific solvent as well. Ionic compounds like NaCl, which are composed of positive and negative ions, forming a crystal lattice array, will dissolve in water. When table salt is placed in water, the water molecules will find their way into the salt. The slightly negative end of the water will attract positive ions and surround them, while the slightly positive end of water will attract negative ions and surround them. The end result is the dissociation of positive sodium from the negative chlorine, also known as dissolving. Here's a brief little video of water dissolving salt.